The interstellar visitor known as 3IR Atlas represents one of the most fascinating cosmic events observed in modern astronomy, capturing the attention of scientists and the public alike as it passed through our solar system in 2025. As only the third confirmed interstellar object ever detected entering our cosmic neighborhood, following Oumuamua in 2017 and 2IR Borisov in 2019, 3IR Atlas offered researchers a rare opportunity to study material formed around another star. Discovered by the Atlas Survey System, which constantly scans the sky for near-Earth objects and transient phenomena, the comet was quickly identified as something unusual due to its extreme velocity and highly hyperbolic trajectory. Its path through space made it clear that this object was not bound to the Sun's gravity and had originated far beyond our solar system, likely traveling for millions or even billions of years before briefly intersecting with our region of the galaxy. On October 29, 2025, 3IR Atlas reached its closest point to the Sun, known as perihelion, where intense solar radiation began heating its icy surface, triggering strong outgassing and the development of spectacular jets and a glowing coma. After this closest solar approach, the comet began its journey outward, gradually fading as it moved away from the Sun's warmth, yet not before making its nearest pass by Earth on December 19, 2025. Even at this closest point, however, the object remained at a distance of about 1.8 astronomical units, or roughly 168 million miles, placing it farther away than the Sun, Mercury, Venus, and Mars typically are from Earth. While this distance meant there was no danger to our planet, it was still close enough for advanced telescopes and space-based instruments to collect valuable data, allowing astronomers to analyze its structure, composition, and behavior in unprecedented detail. One of the most remarkable aspects of 3IR Atlas was its extraordinary speed. Traveling at approximately 130,000 miles per hour, or 210,000 kilometers per hour, it set a new record for the fastest-moving visitor ever recorded passing through our solar system. This immense velocity reflected both its interstellar origin and the additional gravitational acceleration it gained while passing near the Sun. However, scientists soon noticed that the comet's motion could not be explained by gravity alone. Precise tracking data revealed subtle deviations in its trajectory, indicating the presence of non-gravitational forces acting upon it. These findings were discussed in detail in a scientific paper published on December 9, 2025, in the research notes of the American Astronomical Society. Using observations from multiple spacecraft and ground-based telescopes, researchers concluded that the additional acceleration was caused by asymmetric outgassing. As the Sun heated different regions of the comet's surface, volatile substances such as water ice, carbon dioxide, and carbon monoxide sublimated and escaped into space, producing jets that acted like tiny thrusters. These jets gently pushed the comet in various directions, altering its motion in subtle but measurable ways. While some speculative voices on social media had suggested that the unexplained acceleration might indicate artificial propulsion or extraterrestrial technology, scientists firmly dismissed such claims, emphasizing that outgassing is a well-known and well-understood phenomenon in cometary physics. In response to widespread public curiosity and online speculation, NASA organized a major press conference on November 19, 2025, to present the latest findings and reassure audiences about the true nature of 3IR Atlas. Associate Administrator Amit Kshatriya opened the conference by clearly stating that the object was a natural comet originating from another star system and showed no evidence of artificial construction or intelligent control. He highlighted the rigorous scientific methods used to analyze the comet's behavior and stressed the importance of relying on verified data rather than sensational rumors. During the event, NASA released a series of images and videos collected by various space missions, showcasing the comet's evolving appearance as it moved through the inner solar system. These visuals revealed a bright coma, an extended tail, and multiple jets of material erupting from its surface, all consistent with intense solar heating and volatile sublimation. The press conference played a crucial role in shaping public understanding of the event, demonstrating how scientific institutions address extraordinary discoveries with transparency and evidence-based explanations. Among the many spacecraft that turned their attention toward 3IR Atlas, the Mars Reconnaissance Orbiter achieved the closest direct observation. On October 2, 2025, when the comet was approximately 19 million miles, or 31 million kilometers, away from Mars, The orbiter captured high-resolution images that provided valuable insights into the object's structure. These observations allowed scientists to study the shape and brightness of the coma, measure the distribution of dust and gas, and identify active regions on the nucleus responsible for jet formation. By comparing these images with data from Webb Space Telescopes and other space observatories, researchers were able to build a comprehensive picture of how the comet responded to solar radiation and how its physical properties compared to those of comets formed within our own solar system. The involvement of multiple missions illustrated the collaborative nature of modern astronomy, where space agencies and observatories worldwide work together to maximize scientific returns from rare events. In addition to professional observations, amateur and semi-professional astrophotographers played a significant role in documenting the passage of 3I Atlas. Renowned observers such as Michael Jagger, Gerald Riemann, and Enrico Prosperi captured stunning images of the comet as it emerged from its closest encounter with the Sun and became visible in the eastern pre-dawn sky. These images, shared through platforms like the ICQ Comet Observations Facebook page, showcase the dynamic and evolving nature of the object, revealing intricate jet structures and subtle variations in brightness. Their work demonstrated how dedicated amateurs, equipped with modern digital cameras and telescopes, can contribute meaningfully to scientific knowledge and public outreach. By providing frequent updates and high-quality visuals, these astrophotographers helped maintain global interest in the comet and allowed people around the world to witness its beauty, even without access to professional observatories. As 3I Atlas continued its outward journey, it began to display increasingly complex patterns of activity. Multiple jets of gas and dust streamed out in different directions, creating a chaotic yet mesmerizing appearance. These jets were shaped by a combination of factors, including the comet's rotation, surface composition, and the uneven distribution of volatile materials. As certain regions received more sunlight, they became more active, while others remained relatively dormant. Over time, changes in solar illumination caused different jets to strengthen or fade, resulting in a constantly shifting visual profile. Studying these patterns allowed scientists to infer details about the comet's internal structure and thermal properties, offering clues about the conditions in the distant star system where it originally formed. Because interstellar comets are believed to originate in protoplanetary disks around young stars, they may preserve pristine material from the early stages of planetary formation, making them valuable time capsules of cosmic history. The scientific importance of 3I Atlas extends far beyond its brief visit to our solar system. Each interstellar object provides a unique opportunity to test and refine theories about planet formation, stellar evolution, and the distribution of organic compounds in the galaxy. By analyzing the chemical composition of the gases released by the comet, researchers can compare them with those found in solar system comets and interstellar clouds, helping to determine whether planetary systems across the Milky Way share common building blocks. Preliminary studies of 3I Atlas suggested the presence of familiar molecules, supporting the idea that the processes leading to comet formation may be universal. At the same time, subtle differences hinted at variations in temperature, radiation environment, and elemental abundance in its home system, emphasizing the diversity of planetary environments in our galaxy. The public response to 3I Atlas also highlighted the powerful connection between astronomy and human imagination. For many people, the idea of an object traveling between stars and briefly visiting our solar system evokes feelings of wonder, curiosity, and existential reflection. Social media discussions range from scientific analysis to philosophical speculation and science fiction-inspired theories. While some misinformation circulated, the overall reaction demonstrated a strong desire to engage with real scientific discoveries and to understand our place in the universe. Educational institutions, science communicators, and media outlets used the event as an opportunity to explain concepts such as astronomical units, orbital mechanics, and cometary physics, thereby increasing public scientific literacy.